Welcome back. Um, this is the lecture for Chapter 2, which you can't see yet, but uh, you will. This is a real trip down memory lane for me, as is most of this course. And I have some supplemental materials that will be part of this lecture that could be on the quiz. So the chapter title is Learning and Adaptation. And talks about learning as an evolved mechanism to allow animals to deal with their environments. If we were, filter feeders floating around in an amorphic ocean with no predators, if you could imagine that kind of world, learning would probably not be that important. But we live in a world with rocks and trees and now doors and stairs and predators, and we chase after things if we're not busy being chased after by other things. So learning is an evolved mechanism to deal with real life, with the environment. Evolution is important here. And I'm going to give you an operational definition of learning. Operational definitions. If I told you that somebody in this classroom, of course, there is no classroom, but somebody really liked you and they wanted to go out with you, one question you might reasonably ask me is, how do you know? What evidence do you have to support that position? And operational definitions are relevant to that question. So here we go. I don't think I'm going to type this on the website, so you better write it down, and arguably every word is important. So learning is a relatively long-term change in behavior potentiality based upon experience, period. Let me say that again. Learning is a relatively long-term change in behavior potentiality based upon experience. Most of those words are vital in terms of defining what is learning and what is not learning. Relatively long-term. You're studying for a quiz, you're listening to this lecture, you're hoping that information goes into your brain and it changes your potential for answering questions in the future. Now, the longer we go from the original learning experience to the testing experience, there will be a degradation, but it's relatively long-term. And why do we have this qualifier? Well, one is if you're eating something and because you ate it, you don't want to eat it anymore, that's really not learning. And if you become fatigued because you're doing something and you stop, that's not learning. So learning is a change in behavior potentiality. There's the word you're going to have trouble with, potentiality. What's that there for? Hi, my name is Tim. I know my phone number. I have the potential to tell you my phone number if it's relevant to the situation. That's potentiality. In other words, learning does not need to be demonstrated 24/7. It just needs to be able to be identified as needed. It's a potentiality. and it's based upon experience. And this overlaps with the relatively long term. It's and the book has been talking about this, but it's not. Oh, I've had enough to eat. I don't want any more. I'm tired. It's because you've interacted with the world, and the world has changed you. So let me just say it one more time, and you had better be ready to say this back and explain it. Learning is a relatively long-term change in behavior potentiality based upon experience. And learning is an evolved, then that's the end of the definition. Learning is an evolved mechanism. It actually, there's not one learning, there's many learnings, and there are multiple evolved mechanisms. And, the book is spending a lot of time differentiating between classical conditioning and operant conditioning. And in my day, back when I think this author was also in school, there was a grand canyon between those two fields. They did not overlap. Now they overlap so much they're discussed almost simultaneously. Almost simultaneously. So because it's the right thing to do. We were wrong in my day. We ignored classical conditioning. We ridiculed it. As I've said before, we were Americans. We were capitalists. We want that classical conditioning where the environment controls you. We wanted free will organisms doing what they want, engaging in capitalism, doing the free market with their environment, investing their behaviors, deciding whether they wanted to do the behavior again in the future. And we were wrong. Classical conditioning is really important. Now, if you want to go into a clinical discipline and deal with things like addiction or fear, you have to learn about classical conditioning. So there's evolution by natural selection, and we're going to touch on some of that again. And there's a discussion of the Galapagos Islands and the Grants, husband and wife team who've been studying finches on the Galapagos for a very long time, and they have been able to see evidence of evolution in the current birds across their study length. And of course, you saw that video with the bacteria evolving and dealing with antibiotics. And we are watching COVID evolve. Hopefully, we can stay ahead of it. So Darwin was not obsessed with his finches. When he got back to England with his dead finches, he thought they were quite different. They were not one type of bird that had differentiated, but he took his animals to Museum of Natural History, and the bird expert said, "Well, these are all finches." And Darwin had to sit down. He was shocked. And the curator said, "Well, where did you get them?" And he said, "The Galapagos Islands." And he said, "Yeah, well, which bird came from which island?" And Darwin hadn't written it down. But his Captain Fitzroy, had written it down. And Darwin was able to identify the islands and which finches came from them, thanks to Fitzroy. And Darwin had noticed that the tortoises looked different on different islands. That he wrote down, but not the finches. And Fitzroy felt so bad in later life for providing evidence that promoted Darwin's theory of evolution by natural selection, that he killed himself. This was very real stuff back in the day. It's hard to overestimate how life and death this was. One of the reasons that Darwin took 20 years to publish his first book, um, he was publishing lots of other things, was that his wife was not a big fan. There was real fear that she would go to heaven and Darwin would not, and there was depression in the family, and yeah, it wasn't very good. So Hamilton is a big name, although we're not going to be dealing with him very much in this book, but very clever, very important to modern evolutionary theory. E.O. Wilson. I love this quote. The organism, you are essentially the gene's way of making more genes. And relevant to that is Richard Dawkins. We are lumbering robots. I don't have the quote in my head, who go through life promoting genes. We don't have to be at the mercy of our genes of our genes, but you can slip into that. Now there's some books relevant to this, and I posted links on them. When I first came to Scranton, I was low human on the totem pole, and I had to teach what nobody else wanted to teach. And we had a course called Human Behavior, and nobody wanted to teach it. We had created it based on a deal with criminal justice, and we presented it as fundamentals of psychology 2. And criminal justice majors had to take both. I don't know if anybody else had to also. And I was assigned that class. And the person before me had chosen to teach that class using 3 small books. And I couldn't get all of his 3 small books. And one of the books I stumbled onto was On Human Nature. Now, On Human Nature, the link I'm giving you is to a revised edition, but the original edition won the Pulitzer Prize won a Pulitzer Prize in literature. Very few science books do that. If you want to read more on this, I recommend this book. The first couple chapters are kind of dry, but it gets better. I must have 3 or 4 copies of this, and they're heavily marked up. So here's a link to our friends at Amazon. And there's the 25th anniversary edition. I bought that one. I had the original one. And Pulitzer Prize. I mean, how many Pulitzer Prize winning books have you read? And why did Wilson write this? He wrote a book called Sociobiology, and it was about societies, and he's an ant person. So he did ants, and he did birds, and he did wolves, and he did a lot of things. And everybody loved his book, but the last chapter, man, was about applying, and if you looked at my homepage, applying evolution to human behavior. Biology is the study of life. Evolution is the foundation of biology. And he, as his capstone chapter, he did human behavior. People went crazy. They threw water at him. They tried to attack him. It was terrible. And he thought, well, this book, Sociobiology, uh, which, by the way, I've never read all the way through. It's a very heavy book, heavy on math. Whoops. It's in the library. I took it out of the library. So, 2000, that's the 25th edition. It's not cheap. I think I have that edition there. Whoa. I didn't pay $217. But that was Wilson's book. And, you can look at the cover, and if you look carefully, humans are there, but so are a lot of other species. Nobody cared about him talking about ants and birds and wolves, but oh man, did they go nuts on him for having the nerve to indicate that humans could be studied using this perspective. Get used to it, man. So that's a good read, and it's not very expensive. I'm sure that's in the library as well, but it's an inexpensive book, something arguably you might want on your bookshelf. Now, Richard Dawkins, I just watched some videos by him today because I was celebrating Darwin Day, and if you go to my homepage on Facebook, and you don't have to be my friend, you can hate me, and go to my Facebook page. There we go. There's one of my Darwin posts. This guy was bright. Freedom of thought is best promoted by the gradual illumination, which, by the way, is the way he viewed evolution, of men, he was a bit sexist, minds, which follows from the advance of science, Charles Darwin. And if you look down here at the text, there's two links. One is with Daniel Dennett. I'm a huge fan of Dennett. And there's a nice discussion between Dawkins and Dennett. It's from 2009, just after Dennett dodged death from an aneurysm. And that's a nice talk. And then Steven Pinker, who's a psychologist, a linguist, a cognitive psychologist. He was at MIT, now he's at Harvard, which is where Wilson was. And he's got great hair. Oh my God. I would kill for his hair. And of course, I put up this picture again. And there's my brother. And I don't know if you're reading about these mini brains, but they're a little creepy. And you insert what are probably Neanderthal genes in there, and things change. We probably had better brains than Neanderthals. And I'm sorry, this is what I do every morning for about an hour and a half, post things. We can talk to Voyager 2, which has left the solar system. Very good thing. So I think that's it for those two. And we'll deal with some of these other things a bit later. So when I taught this course, when I first came back to Scranton, as an undergraduate, I was never exposed to evolution. As a graduate student, I was barely exposed to evolution. And then when I got here, I read a Pulitzer Prize-winning book by E.O. Wilson, and Daniel Dennett, one of the videos, talks about evolutionary theory as being like a universal acid. And he said as a child, he used to, think about if you had a universal acid that could melt through anything, sort of like the original Alien movie, which probably doesn't mean anything to you, the blood of the alien could melt right through the deck of the ship. I always wondered where it went after it got done with the deck. And, if you have a universal acid, Dennett said, how do you contain it? It just keeps creeping and eating other parts of your world. And that's exactly what happened to me. I used to annoy the heck out of my peers because virtually no matter what they were doing, I was talking about the relevance of evolution to their discipline. The social psychologist who was here back then, boy, did he resist. But in the end, the acid ate him too. This is a nice story about evolution. It's not an experiment, but we changed the environment of Europe because of just really the next page, because we polluted it, which we are still doing. And boy, a lot of people are dying because of polluted air. We don't think about it, but when I moved to LA for my postdoc after I went to grad school, you could feel the air, literally feel it, and it burned your lungs. And the Environmental Protection Agency was invented about then. And boy, they did good things with the air in LA. They did good things with the water in Maine. A dead river that stunk to high heaven because of paper mills. By the time I left graduate school, they were catching salmon in that river. Ethology. This was European. We liked behaviorism. We liked Skinner. We didn't like Pavlov. We didn't like ethology. We fought against this too. And several ethologists shared the Nobel Prize. And we were very upset that B.F. Skinner didn't get any of that action. They were right. The ethologists were right. And I had to take my subspecialty was animal behavior. And because of that, I was exposed to ethology pretty heavily. Nico Tinbergen, I bet he was a very interesting person, and he did the gull research that's very important. And retrieving eggs from nests and what children the babies would do to peck at the dot on the gull's beak, and removing broken shells, and why do they do that? And it looks like if you don't remove the broken shells, predators see them and then they find your eggs, and then your eggs are dead. So much time thinking about fixed action patterns. For short, we call them FAPs. F-A-P, little s, FAPs. There, we talked about releasing stimuli, and we also talked about supernormal releasing stimuli. And by the way, there's some of the research on the herring gulls revealed that. I think that's in here somewhere. You can get them to retrieve eggs that are not their own and ignore their own if you make the fake egg correct. And there's Eibel Eibesfeld. You can tell that there's some Germans involved here. And he did a lot of really good work. And there's these pictures. They're exactly from the book I studied when I was in graduate school. And I graduated from the university in 1970, and these were in textbooks in 71. They are, I just, every time I look at these pictures, you can't help but smile. They're delightful. And he did some of that research. And innate behavior versus learned behavior. This is learning and behavior. And fixed action patterns tend to be, they can be directed, but they are fixed. They are fixed action patterns. They are FAPs. And the natural selection, of course, is what Darwin talked about. But Darwin had farming in his family history, and he could see that farmers were selecting cattle and horses, and I think his mother raised pigeons. You can't believe what they can do to pigeons with artificial selection, and you can do artificial selection on behavior. I almost defy you to find some behavior or physical trait with variability that you cannot shape for. And by the way, shaping is in this chapter. And the bright and the dull rats. I forgot. I was a behavior geneticist. I didn't do genes, but we selectively bred rats back in my day. For those that really did not like loud noise, they would hit a lever to turn it off, and others that just didn't care. And it didn't take many generations of breeding to get those animals separated. Sometimes to the point that if that became an important issue for whether you'd have sex with another rat, they didn't even overlap. It could have made it so they wouldn't interbreed anymore. And there's pecking at beaks. This is fun stuff. I really enjoy this. Habituation is going to be a big part of this course. I'm afraid to say the word hind or Hindi. That was my animal behavior book. I think 2 years ago, we had a biology major who said they wanted to go into animal behavior, and I thought, well, I'm old. Maybe it's time to let go of some of my favorite books, and I gave them my book. So there's habituation and some spontaneous recovery. Startle. Startle. That is what I did in grad school. I did my dissertation on acoustic startle, and there's habituation and recovery. Oh wow! I was so focused on Hinda that I missed the startle. That's what I did. So there's habituation, something that's important to know. Nice little discussion. This book really is quite good. Spontaneous recovery, we're going to be dealing with that quite a bit, and you saw that in the other figure, that habituation had occurred pretty substantially, and then you give the animals time away, and when you put them back in the situation, behavior comes back. By the way, this is a huge issue. If you're dealing with addiction or love or fear, and therapists have to be aware of this, as does society. So, and these terms, dishabituation, an important term. I remember being at a neuroscience meeting with a current student who wanted to do some fancy classical conditioning, and she wanted to talk about dishabituation, and she could see that I was not deeply trained in it. And she said, "Oh, never mind. Your former student is at UCLA with Fantelo. She will understand." And boy, she did. Um, I still must have a little bit of aversion to classical conditioning, and more graphs, amount of salivation, responding uh, to food, and they tend to covary. They don't always covary, but they tend to covary. Um, you can get sensitization. Um, Sometimes a loud noise will increase later responses to moderate noises. Um, and that's an important learning phenomenon, the dual process theory of habituation. Groves and Thompson, yes. There's not a ton of this information in this chapter, but we will deal with that in greater detail later in the textbook. And there's Bowles, who I've already mentioned. Bowles was the advisor of the person I'll introduce you to in a bit, who became the advisor of a Scrantonian who my student had to talk to at neuroscience because they understood classical conditioning better. Bowles was a very impressive person, and he was also lifelong crippled from polio. And instrumental conditioning as opposed to operant. And there's a nice discussion, interactions between babies and parents, and law of effects. The concept sort of stamping in and stamping out. So there's a nice discussion here and a figure that I'm not hugely in love with. So I'm giving you a different figure, and this is testable. So here's my figure. When you have to choose between the book's figure and my figure, pick my figure. And these cells will lead to operational definitions, like the operational definition of learning, a relatively long-term change in behavior potentiality based upon experience. You have to be able to operationally define things in these tables. Whoops. Oh my God. Let's hope I can control this. I know. I will go to the published version. And there it is. Okay, so there's a 2x2 table. 2 over, 2 down. And then there are column labels and row labels. You must know them both. And both of them will help you with the operational definitions I'm going to ask you to know. Perhaps I should go to a larger format. There we go. Okay. On top, contingent on behavior. What the hell does that mean? Contingent means dependent upon. If you don't say contingent on behavior or dependent upon behavior, you're going to lose some serious points. This is instrumental conditioning. This is operant conditioning. This is capitalism, where the organism invests its behavior in the real world and things change. So at the top, contingent upon behavior or on behavior, you can add or remove a stimulus. Probably need a comma there. So the plus symbol means add. It does not mean what your brain is going to ask you to think it means. And the minus symbol means negative. So you have positive and negative. And then on the left side, because of what happened, because of contingent upon behavior or stimulus is added or removed, the probability behavior goes, whoops, this figure needs to be fixed. It will be by the time you get to it. This arrow down here, I meant to move it. This will be up here. So this arrow will be up and it will say increase the probability behavior. And down here will be decreased probability behavior. So the way to get your points is to say contingent upon behavior, a stimulus is added or removed from the environment, and the probability of behavior increases or decreases. I'm really sorry, I meant to fix those arrows, but they will be right by the time you look at this later. Oh, and they're right now, so I just didn't fix them in that figure. Okay, so notice the up arrow, the top arrow is up and the bottom arrow is down. So now we can fill in our cells. Notice that under the positive symbol, you have two positives. Who would have thought? So contingent upon behavior, if something is added, that's positive. That sure as heck doesn't mean it's good. It's good. And notice that, parallel to the up arrow is reinforcement and reinforcement. So only if the probability of behavior goes up is it reinforcement. In other words, the animal tells you. It's like good touch, bad touch. You may intend your touch to make someone happy, but if it doesn't, that's not your call. That's their call. And so the same stimulus, even for some animals, can increase the probability of behavior, positive reinforcement, but for other animals, contingent upon behavior, a stimulus is added. The very same stimulus sometimes. For example, if you're ever hungover, stimuli associated with food are pretty aversive, and the probability of behavior will go down. So every one of these cells, you look at it, upper left-hand corner, and you say contingent upon behavior, a stimulus is added to the environment, and the probability of behavior goes up. That's positive reinforcement. And surprisingly, but you've got to learn it, relatively long-term change in behavior potentiality, contingent upon behavior, a stimulus is added to your environment, and the probability of behavior goes down. When we think about reinforcement, we largely think about the upper left-hand cell. Candy. I remember being in grade school and I was nuts for the little stickers the nuns would put on my work. Oh, I love pumpkins. So that's positive reinforcement. And to overstate, so you remember it, positive punishment, I whack you upside the head. Give you a dope slap, as the Click and Clack, the Tappet brothers used to say. So you do something, and contingent upon your behavior, I give you a dope slap, and that is supposed to decrease. Never say it's supposed to. Never, ever. Major points will be lost. Remember, it's not up to the person doing the slapping to decide whether the other person's behavior will go up or down. It's up to the recipient. So contingent upon behavior, a stimulus is added to the environment, could be a slap, and the probability of that behavior goes down. That's positive punishment. That does not mean good punishment. That means punishment that's contingent upon the addition of a stimulus. Once you get this figure, it won't be challenging. But until you kind of fight your natural tendencies, this can be challenging. And now to the right column. So contingent upon behavior, a stimulus is removed, and the probability of behavior goes up. So I used to deal with escape from noise. So we would turn on noise, and if the rat hit the lever, the noise would go off. And for some rats, the probability of behavior would go up. So in that situation where the noise is already present, that's called escape, because bad things are already happening. But you can also have situations where you have to hit the lever to keep something bad from happening. That's avoidance. That's harder for animals to do. It's harder for people to do. But escape and avoidance live in that upper right hand cell. Very important things. And then down the bottom is something that sounds like your most horrible nightmare. Oh my God, it's not only punishment, it's negative punishment. Well, it just means contingent upon behavior, a stimulus is removed from the environment, and the probability behavior goes down. We have decided that it's uncivilized for us to hit people. America went nuts when some tourist in Taiwan or something littered or wrote graffiti, and they were going to whip him with a bamboo rod. That would be positive punishment. And we decided that was really uncivilized. And for us, what's civilized is negative punishment, where you pay a fine or something. Of course, fines for poor people, fines may control behavior very well, but for wealthy people, you really have to crank up your fine. The president of Nokia in Finland, where they do things right, your traffic tickets are adjusted by the value of your vehicle. And boy, did he pay a fine for speeding. And I think that's it for this figure. So the arrows are correct here. The arrows are not correct there. You should be able to define all of those, contingent upon behavior, stimulus is added or removed, and the probability of behavior goes up or down. You should know where, our criminal justice system uses fines. Often in laboratory animals, electric shock and noise can be used for negative reinforcement and positive punishment. We use electric shock there lots. And we're going to see some videos of pigeons working for positive reinforcement. So know that figure and be able to identify those 4 cells. That was fun. Okay, back to the chapter. Looks a lot like this figure, and it's this figure is not wrong. I just think my figure tells a better story. But I'm not going to tell the author of this book because he already tells lots of my stories. So there's positive and negative reinforcement, shaping. I've already used the word in a sentence. I remember my peers who worked with pigeons in graduate school, they loathed shaping pigeons to Pekis. They hated it because it was so painful to have to do. When I was an undergraduate, when I was you, we all had our own rats for this class, actually. And you had to shape them to hit the lever. And boy, was the instructor very picky about what the lever pressing was supposed to look like. We've all been shaped. And they're shaping in human language, which is a big issue for Skinner and other folks. Lovaas. Oh my God. I used to ride the elevator with him at UCLA, and he developed a very effective training program for autistic children. When I first came here from UCLA, some local parents knew about Lovaas, and they were desperate to find people who could do the Lovaas method. That exists now. We have that. And we have therapists that do it, but not back in those days. And he was a very colorful guy. uh, blonde hair, big gold chains, Hawaiian shirts. He was larger than life. And now we're talking about, shaping of different kinds, force, numbers. This is an important figure. And it relates to moving from high school to college, by the way, and also from grade school to high school sometimes. When I was in grade school, man, you got your letters between the lines, and you got anything down the page, and you got your sticker. Presumably in high school, things got more difficult. In colleges, man, they had better get more difficult. And some of you are not providing very comprehensive answers, and I will shape you. Don't make me. Um, if high school is number one and college is number three, they don't overlap. And we used to use software in this class, Sniffy the Virtual Rat. And I used to do a demonstration on shaping, and it wasn't programmed correctly. And every time students tried to get Sniffy to do this one thing, it had really been done in the real world, and animals did adapt, but not Sniffy the Virtual Rat. So if you move too quickly, you lose the organism, and students hate school, and they feel like they're working really hard, and they're not getting their stickers. They're where's my pat on the head? Where's my happy face? So, you know, we should be attentive to this. But on the other hand, this is college, man, and we have a duty to do a good job. The United States' primary and secondary education is not good. In fact, there was a national study done where the report said if a foreign country had come in here and done this to our educational system, we would declare war on them. But boy, our colleges and our graduate programs are excellent. And so I know some of my peers kind of let things slide, but I would like to think I don't. And there's a discussion of the whelks and evolution and natural selection. And then there's now we deal with some classical conditioning. And Pavlov and his drooling dogs. And salivation. Remember, did I mention this? Pavlov had already won the Nobel Prize for other research he had done before he started dealing with classical conditioning. But gastric juices are important for. I'm sorry, salivation is part of the digestive process. And there's beloved John Garcia, such a fan of his. He used to prowl New England, going to barn sales, buying weird things from, like 1890. And he kept them in a back room in his house, and he would bring you to his house, and you would have to guess what these things did. And boy, it was tough. Garcia's lab was right down the hall from the lab I was in. Very impressive guy. And he got his start in psychology and science relatively late in his life, but boy, did he crush it. His early research on taste aversion learning, I may slip and call it poison avoidance learning. It has many names. Classical conditioning journals wouldn't publish it because they said it wasn't classical conditioning, because they were anal, they still are anal, and they didn't want to publish it. And they had decided that if the delay between the conditioning stimulus and the unconditional conditioned stimulus was longer than maybe 2 seconds, it was not real classical conditioning. And he was dealing with things like a half hour or an hour. He, of course, was right. And taste aversion learning is a very big deal. And poison avoidance, there's tequila. Things that are sweet are easier to learn. Taste aversion too. And there's a phrase, the sweet smell of death. I could sometimes walk into an animal colony, and by smell, I could figure out if an animal had ceased to be. He was brilliant, and he was kind, and he was gentle, and he was funny. I miss John. Oh, and there's a name I didn't mark. Fanslow. So we're going to see a lot of Fanslow, and Bowles was Fanslow's advisor in grad school, and Fanslow was my student's advisor in grad school. So there's an educational pedigree there that is pretty cool. So Fanslow was coming to UCLA just as I was leaving. I'll leave it to you to deal with this territoriality and reproduction. It's good stuff. It shows how flexible these concepts can be. There are nice data there in terms of how many bites or tail beats you get. And we're about to see soon, because males and females respond differently to the opposite sex when they're in the zone, and that's being manipulated here, whether you're dealing with bites or courtship. And there's Damian, not Damjan, and the book you're currently using, as I think I've already said, I originally used his book until he put the the stupid kissing elephant on the cover. I have more respect for my discipline, and that's a Scrantonian, Michael Mahameta, who went and did his PhD in the Damian lab. And back in the day, I could have shown you a photograph of Mike, but that was on university servers that they shut down, and I lost all my pictures. Very sad. And Japanese quail, that was one of the species that Damian liked working with. Fear. Now we're in my world again. The Blanchards, boy, they're big back in the day. And there's Bowles. Oh my God, Boughton and Bowles. That's interesting. So maybe I knew this, that Bowles was also Boughton's graduate advisor. And my lab fought a lot with Michael Fanslow before he came to UCLA over fear and fear conditioning. He was very clever, Fanslow. We would just shock him, the animals, to produce fear. But he was from the Bowles lab, and they worried much more about evolution. The lab I was in did not. And Bowles, or Fanslow, has done some really, really clever research. So at the bottom it says the fear system elicited by danger signals a signal for electric shock induces a state of analgesia. Now, analgesia means without pain. That's overstated. Hypoalgesia would be better. But certainly frightened animals are less sensitive to pain. And often the analgesia is caused by release of endorphins, natural opiates. Natural opiates are opioids. So I prefer the term opioid for what's natural and opiates for the drugs we take. And it does say often. And in a second, I'll show you why it's not always. Fanslow, okay. So, Fanslow had a beautiful theory about all this, and I tried to come up with a theory of all this in my doctoral dissertation. No surprise, Fanslow did a better job. But just to show that I used to do stuff. So here's opioid, which means natural, what you make, and non-opioid, which means it's natural and you make it, but we don't know what the heck it is. Stress analgesia, and like Fanslow, we use electric shock, although we didn't do classical conditioning and learning. So this is just an abstract, which I'm not going to test you on. So there's the journal Science. There are two premier journals on Earth. In the United States, Science is the premier journal, and in Europe, the premier journal is Nature. And there's a Scrantonian who has publication in there. So there's my good friend Jim Lewis, who got married in my basement. There's me and John Liebeskind. I miss him still. He, by the way, at Harvard was taught by B.F. Skinner and kept a picture of B.F. Skinner on his corkboard because B.F. had given him the only C of his academic career, and he never forgot it. So inescapable foot shock, that's how we stress them. Profound analgesia. And there's naloxone, which I think has already come up. Now, naloxone blocks opiates and opioids. And dexamethasone, I forgot. Dexamethasone is in the news again with COVID. This is one of the drugs that we give to treat some COVID symptoms. It suppresses inflammation and it can save your life. So we had two kinds of stress, intermittent for 30 minutes, 1 second on, 4 seconds off for 30 minutes, or continuously for 3 minutes. I never liked this abstract. It talked about temporal mechanisms. It was the duration. It was not the pattern. Certain forms of stress may act as natural inputs to endogenous opiate analgesia system. And I don't like that either because we were ignoring the non-opioid. And I did some later research where the non-opioid was anatomically independent. And we now know that the non-opioid involves endocannabinoids. And it's what marijuana taps into, and it doesn't generate tolerance and cross tolerance. We really missed the boat there, but of course, the federal government was suppressing research on opiates or marijuana back then. Now we're about to come up on the next topic, and there's Shepard Siegel. I was bad. I was in graduate school when he published his first article on this topic, and it was in the journal Science, which I subscribed to. And I got the journal and I saw the study and I ridiculed it. He believed that classical conditioning, which as a red-blooded American I didn't like, was important for tolerance to opiates, tolerance to drugs. And Tim was wrong again. This is important stuff. And again, if you're going to be dealing with addicts or people in love, or you really have to understand classical conditioning. And his research was brilliant. I was stupid. And there's a graph showing you the theoretical underpinnings of his classical conditioning model. So on the left, the red line is what the overall body does. Now the body is, billions of neurons, working in symphony, and it's yin and yang all over the place. But the overall behavioral output of that mess is drug tolerance. But Siegel said that the direct drug effect, remained stable across trials. The drug was the same. What changed was your body learned to compensate for it. And that's brilliant. And that's love. And that's why people break up, because it's not magical anymore. Get used to it. And now we used a tail flick response where we heated the tail until it flicked. Here we talk about a hot plate, where you make the plate relatively hot, and after about 10 to 20 seconds, the animal will lick its paws or jump. So those are pain behaviors. And testing in the same or different room, Shepherd 1975, that may be the one that I laughed at. I was bad. I was wrong. And Siegel is still famous to this day. So there's lots of discussions of research relevant to Siegel. Obviously, this author's like me. Maybe he didn't laugh at Siegel back in the day. But obviously, he thinks that this is important stuff, and it is, as is John Garcia's stuff on poison avoidance, sign tracking. This is something else that came out while I was in graduate school. And here's a 2x2 table, but I'm not going to talk about it, but you should look at it. I told you that my peers who were working with pigeons hated shaping them. They would go into a darkened world and watch these pigeons for hours. And pigeons like to peck, but boy, they don't naturally peck at little pieces of plastic. They want to peck at food. And these people would come out bleary-eyed after hours of shaping. Once the animal was shaped, they got it. But shaping was a nightmare. So when sign tracking came out, they should have reacted to it like classical conditioning or Siegel, but in my day, this was called auto shaping, automatic shaping, where you would just throw the pigeon in the box and set your programming equipment correctly, and a miracle would happen according to those people. I never shaped a pigeon. You'd go away, you'd go play frisbee, which we did a lot, and you'd come back in a half hour, and the animal would be in there pecking beautifully. It was really classical conditioning, and it should have been evil communism, not free will. But they were so happy that they could auto shape their animals. And there's positive auto shaping and negative auto shaping. You can read about that. And it's negative sign tracking is negative auto shaping. And again, this author obviously sees how important this was to his field, which was my field, and he does a good job of discovering it. Rescorla, by the way, is associated, as is Garcia, with the concept of preparedness, which you're going to see a ton of. And I think I'm about to show you. And these are parallels between instrumental or operant and classical conditioning. Right, they're related. And there's at the bottom of this page, there's discussion about extinction, clinical psychologists, and therapy. Yeah, you can't be a good clinical psychologist without really understanding this course. Okay, all right. So we will have a little humor here as well. Is this what I wanted? It's not acting like what I wanted. Yes, it is. Oh, okay. This is not. I wanted the real page. Yeah, this is probably okay. It's just a little clumsy. So I still feel guilty over laughing at Shepard Siegel. So here's science again, and he's the sole author, which is huge. Morphine analgesic tolerance. Its situation specifically supports a Pavlovian conditioning model. Rats were made tolerant to morphine in one or two environments. Then they assessed pain sensitivity. This is no doubt where the hot plate was used. Tolerance was observed when animals were tested in the environment in which they had originally gotten their morphine, but not in the novel environment. This was big. Shepard was so right. Okay. Now, I these videos are really quite good. So this is a video of a pigeon auto shaping. So later we're going to talk about this box, but over here is a grain hopper with a little like a steam shovel thing and a solenoid, magnet and wire, electromagnet, will pull this hopper down and put the grain in this opening here, which I think also illuminates. And is, for like 2-3 seconds, the animal can stick their head in here and get some grain, and they're very happy to do that. Up here is the magic. So this is the key that we want the pigeon to peck. And there's a light stimulus that simply by association, no cause any, the programming equipment makes both things happen, but the animal doesn't have to peck the key, and the animal has no control over whether that light goes on. But that light goes on just before or during the time the food hopper comes up. So the light is on, the pigeon doesn't care, and then the food hopper lights up, and the pigeon doesn't care. So this animal has not been hopper trained, because otherwise he'd be right over there. The light is up. Okay, so he's been hopper trained, very happy to eat. And the light goes on. He seems more intrigued. And there's the food. And by the way, these are females. I shouldn't say he. And the light comes on and she's intrigued. And there's the food. And now she's near where the light comes on. And there's the light. And what the heck is she doing? She's pecking at the piece of plastic that covers the light. And she has learned to peck. She has been auto-shaped. This saved so much time for my pigeon friends. But I don't think this is going to be in this chapter, but as long as I'm here, I want to show you this one. So you can have a box that delivers grain, or you can have a box that delivers water. And you might ask yourself, does the auto shaping change, or the sign tracking change? Well, hey, it's down here, sorry. Now notice what the animal's doing with its beak. Notice it's open. Slow motion. And now this is an animal that's a different animal trained for water. Notice she is not gaping with her beak. I forget when this was discovered. It took a while. Back in my day, we had to use film, which had silver on it, which meant it was very expensive. Once videotapes came along, this kind of research became much more possible. Those are good videos. That difference in behavior isn't relevant to this chapter, but it will be relevant to the course eventually. All right, so in a second, we're going to get to this. So exposure therapy and trying to reduce fears, insects, over and over to the stimulus. We sometimes do systematic desensitization where the insect is on the other side of the room and it's in a box, and then you can see it in a cage, and then it gets closer. So there's all sorts of ways to play this. Of course, with extinction, you have to worry about spontaneous recovery, and it can take a long time to do this training. And I used to love the Far Side cartoons, love them. And this is a classic. So Professor Gallagher and his controversial technique of simultaneously confronting fear of heights, snakes, and the dark. That would not work. And that is certainly not systematic desensitization. But the Far Side was brilliant. And yeah, now we're going to go over a number of variables. I can't offer much here, but timing is important. And, delay makes things work worse, which is relevant to punishment and even relative to reward. And church was important to me. He did a lot of good research on the science of electric shock and how to deliver it effectively. And I made good use of that at UCLA. And, there's Garcia's stuff, again, where the delays are long. So it depends. And there's auto shaping and fear conditioning and taste aversion. So it's all good. And they're all pretty parallel. Size of outcome, 8 pellets, 1 pellet, milliamperes. Now that must have been done a while ago. Yeah, 67. Because at the high end there, they were using 2 milliamps. They don't do that anymore. 2 milliamps is memorable, but it does work good. And if you don't want to punish your animal, the punishment should work. Those animals up on top who are getting the baby shocks, they're getting shocked a lot because they're still doing the behavior. If you want something to stop, you want the punishment to be effective. Punishment that doesn't work is not punishment, because positive punishment contingent upon behavior stimulus out of the environment and the probability behavior goes down. If the probability behavior doesn't go down, that's not punishment. Now, here's more modern research, and I've highlighted Holland because one of your students, who then worked with Fanslow, before she worked with Fanslow, worked with Holland. And I always wanted someone to go to UCLA, and I'd like to take credit for her, but Holland wrote her a killer letter. Notice that there the highest shock level is 0.1 milliamps, a tenth of a milliamp, whereas earlier we were doing 2. And back in my day, we used even more. So there's preparedness, which is very important, and there's Garcia, and this is going to be a recurring theme in the textbook. This is brilliant research. Bright, noisy, tasty water. Think about evolutionary history. Now, what signals you that you're going to get whacked upside the head, which is shock in this case? A taste? No. Something you see? Yes. Something you hear? Yes. You are prepared to learn to associate something physically bad to the outside of your body with visual and auditory stimuli. But if you're going to throw up, very rarely do you do it because you hear something or see something. But if you've eaten something that's toxic, yeah. So think about evolution. That was brilliant research. I remember when that came out. I was very impressed. And Damian did a variant on this. And there's BF, who we'll talk about later. And there's the Braylons. They wanted to make money. They wanted to train animals to perform in malls for quarters and stuff. And the animals misbehaved. And they published a study, The Misbehavior of Organisms. And there must be videos of that. We'll see it again later. And there's some golden hamsters scrabbling in the sawdust, and things that they are or are not prepared to associate with food. And we're pretty much done. So this was a fun chapter. You must know the operational definition of learning and the operational definitions that are inside that 2x2 table. I gave you other things I've just given you for fun. So thanks for dropping by, and we'll see you next week.